In this exploration, we use diffraction to measure the diameter of a hair. Do you know that you can use a laser to measure the thickness of a hair?
Really? How do you do that?
First, you tape a hair over the end of the laser. The easiest way to attach the hair to the laser is to put the hair on a piece of tape and then wrap the tape around the laser. Stretch the hair over the laser aperture and tape it in place. I promise it's not photoshopped. Now we need to shine the laser around the hair, like this. On the paper we put on the wall, there's a pattern of bright lines separated by dark spots. We need to mark the locations of the dark spots so we can measure them later. We only have a short ruler, so we can measure the distance from the hair to the wall with a string. We get 119.5 centimeters as our answer. When we take the paper down, we have marks showing the edges of the dark spots. We can fill in with a marker to give a better idea of where the light was. We have to measure from the center of the pattern to the center of the dark spots.
We now have several points. Which one do we use?
We can use any of the points, but we have to keep in mind the order in which they appear, and that will be the m in our equation.
What wavelength do we use?
These laser pointers are usually about 650 nanometers.
Let's plug it into the equation.
What does 77,675 mean to you? I think it means we missed our powers of 10. Okay, so the distance from the hair to the screen was 119.5 centimeters. The wavelength is 650 nanometers. And for the first dark spot, that is m equals 1, we have 1 centimeter from the center of the pattern to the center of the dark spot. This hair was about 78 microns in diameter, which is just about right.